students, today we'll be doing superposition theorem. Again, a second example towards it. Let's work on it. A slightly different sum. So let's be keen for it. If you observe this network, you have only two small loops. Looks very simple and it is very simple. So let's have a look on it. When I talk about superposition theorem, again the same point. You need to solve keeping only one independent source. So when I observe it, I can have a look. There are three sources. One is independent, again an independent, but a dependent. But superposition says you have to solve by using only one independent source in the circuit. So you concluded it. You have two independent sources. One is your voltage source and one is your current source. So that simply tells you have to solve by using two cases. In first case, you have to keep 100 volt. Second case, you have to keep 10 amperes. So let's solve by using 100 volt. Case 1. Case 1 acting 100 volt. When I am saying I need to use 100 volt, that means I need to remove 10 amperes. When I say I need to remove a current source, that means I need to replace a current source by its internal resistance. When I say I need to replace it by internal resistance, the internal resistance of a current source is infinity. That means I need to open circuit the current source. Just make it a point. When the internal resistance is infinity, I need to open circuit the current source. And in case of voltage source, the internal resistance is as good as 0. So I need to short the voltage source. So that's the basic difference between voltage and current. Just keep that in mind. Please put it down this point. Don't forget. So let's do it. So first case, having 100 volt. So this will be a 10 ohms. Again a voltage source. This will be minus plus. This will be 10 Vx. This will be your again a 5 ohms plus minus. This will be your Vx. Again a circuit, because since this current source was kept it open, so you just need to neglect this loop because there won't be any current flowing through it. So you have only one loop, and one loop will have one unknown current, that will be your I1. So let's resolve it. Ultimately, I need to find current across 10 ohms. That means I need to find current I1. So let's solve it by using mesh or super mesh. Let's have a look. If I need to apply mesh, I need to apply KVL. If I need to apply KVL, I need to have voltages. If I need to have voltages, the sum of all voltages should be equal to 0. Let's check it if you have 0 or not. This is a voltage source. This will be a voltage source, I into R. This is a voltage source. This will be a voltage source, I into R. That means all terms are voltages. That means you will be applying KVL. So that's your basic sum for mesh. So let's apply the equation for the same. So applying KVL in mesh 1. So in this mesh, how many resistors you can see? You will say 2. Damn good. So add them. 50. Good. Which current is flowing through it? You will say I1. Good. Third question. What sign convention will be given to I1? Basic rule. If you are applying KVL to any mesh, so that mesh current should be taken as positive. If I'm applying KVL to this mesh, I1 I will be taking as positive. That will be 15 I1 plus. So let's write the equation for the same. Your statement will be applying KVL in mesh we get. I'm not writing 1, 2 since they are only one mesh. So your equation will be 15 I1 equal to, since there are no other currents flowing through it. When I write equal to, after equal to there should be only voltages. So observe the circuit once again, my dear friend. So how many voltages you will be having it? You will say 3. First, second and third. Wrong. Just make it sure. This is not a voltage source. This is the only representation of Vx. It's not a voltage source. So don't include in your equation this term. So you'll be straight away wrong. Okay. So your voltage source is only 2. One is your dependent voltage source. One is a dependent voltage source. One is your independent voltage source. So your current enters into negative. So it will be positive. So you will be getting 100. Second, again your current enters into negative, so it will be positive, it will be plus 10 Vx. You got this equation by applying KVL, but you cannot use it. The rule is that you should be having only unknowns, right? We were clear about it. So which is the extra term you're getting in? You will be saying it, the extra term is Vx. So let's find the equation for Vx. So your equation for Vx, it will be in terms of current. That is nothing but your I1. So let's solve it, the equation for Vx. I need to write the equation for voltage. Simple basic rule, guys. Apply Ohm's law. When I say Ohm's law, V is equal to IR. For V, I'll be writing Vx. For R, your Vx is across which resistance, my dear friend? You will say it 5. In 5, which current is flowing for it? I1. And I1 is entering into positive or negative? Positive. So write as positive. That means for resistance, you will be writing 5. For current, you will be writing I1. And for sign, you will be writing plus because I1 is entering into positive. So that's the way you will be getting the equation for Vx. That will be 5I1. Put the value of for Vx, you will be getting 515 I1 equal to 100 plus 10 into it will be 5I1. Simplified, all the variables should be on LHS. On RHS, they should be only number. So make it clear always in every sum. So this will be 15 I1 minus 50 equal to 100. So here you'll be getting the value for A. Now using a scientific calculator, you'll be calculating the value of I1. So after using a scientific calculator, you got the value for I1. So that's not your final answer. Ultimately in this question, it was asked find the current across 10 ohms. So your current across first case, you can write as current across 10 ohms is equal to current across I1 equal to the value of minus 2.86 amperes. Again, a direction is compulsory in superposition theorem. So let's have a look for direction for 10 ohms. The 10 ohms is placed in vertical or horizontal, but obvious horizontal. That means that there are two options, right or left. Observe, I1 is flowing in right direction, so your direction will be right. So that's your first case. If it is your first case, so denote current across 10 ohms by dash. That's your first case. Let's do it for second case, because in this case you had two independent sources. One was your voltage source, one was your current source. Let's do it for second case, my dear friends. Let's observe it. Case 2. In case 2, you have acting as 10 amperes. That means you need to remove one voltage source. That was your 100 volts. If I need to remove a voltage source, I need to replace it by its internal resistance. And the internal resistance of a voltage source is 0. So I need to short the voltage source. So your circuit will be 100 volts. This will be your 10 ohms. You will be having a dependent voltage source, that will be minus plus 10 Vx. You will be having a resistance 5 plus minus Vx. Again, you will be having a current source. In this case, you have a two small loop. So take two unknowns. Current, one will be I1, other will be I2. Ultimately, I need to find current across 10 ohms, so I need to find I1. Simple as that. But in case 2, since you have two meshes, in fact two loops and two unknowns, one is your I1 and one is your I2. So let's solve for it. In case 2, you considered 10 amperes and you shorted the voltage, that was your 100 volts. So let's have a look if you can apply by mesh or you can apply by supermesh. In this case, I into R voltage, I into R voltage. That means over here you can apply a mesh. In this case, can you have a look? I into R voltage, but this cannot be. And when you cannot apply a KVL in this type of one single loop, that means KVL is only applied to find current. And when you cannot apply KVL, that means in this case you can directly get the current value. Let's have a look how we can get the value. That means I2 equal to, observe it, the value and direction of both of them. I2 current direction and 10 ampere direction. Both the directions are opposite. Since they are opposite, the sign will be minus. If they would be the same direction, in fact, sign of I2 will be 1. Let's write the equation for this. So the statement will be the same. Applying KVL in mesh, we get how many resistors we can see. To add them, it will be 50. Which current is flowing? I. Since we are applying mesh in that, sign will be positive. Check in the whether in this two resistors is there any other current flowing for it? Yes. Which I from where 5 ohms. Your sign will be minus 5. Equal. When you write equal to, after equal to there should be only voltage. So your current enters into negative, so it will be positive. When I say about mesh, the equation should be in terms of only I1 and I2. But in this case, you already got the value 5. The unknown will be only I1. So the equation should have only I1. Other than I1, they should be in. So let's resolve it. Put the value of I2 over here and put the equation for Vx. For finding voltage, basic formula V is equal to I, right? So let's use it. For V, you will be writing Vx. Vx is across which resistance? 5. So for R, you will be writing 5. In 5, which current is flowing? You will observe carefully. Even I1 is flowing and I2. Both the current. So both the current are flowing. How to write the equation? Observe the sign convention carefully. I1 is entering into positive and I2 is entering into negative. So use that convention to be plus I1 minus I2. That will be your condition for Vx. So Vx will be 5I1 minus 5I2. So put the value of Vx in the above equation. So Vx you got is 5I1 minus 5I2. So put this value of Vx in this. So you get 15I1 minus 5I2 equal to 10. The value for Vx you got is 5I1 minus 5I2. Simplify it. You get 15I1 minus 5I2 equal to 50I1 minus 50I2. Shift all the variables that side because LHS should be the only variable, RH should be only numbers. So you'll get, my dear friend, 15I1 minus 5I2 minus 50I1 plus 50I2 equal to 0. So this is your I1. So 15 minus 50 is nothing but equal to minus 45I1 minus 5 plus 50 will be plus 45I2 equal to 0. That will be our equation. But in this case, you already got the value for I2. The value for I2 is nothing but minus 10 amperes. So for this value over here, you'll get the value for I1, which will be minus 35I1 plus 45 into minus 10 equal to 0. Simplify it, you'll get the value for I1. So by using a calculator, you might have got this value, that is your I1. Ultimately, friends, you have to find the value across 10 ohms, right? So this was your case 2. So you'll put down the value in such a manner. Current across 10 ohms is equal to I1 is equal to minus 12.86 amperes. Direction is compulsory because the resistance was placed in horizontal, so your direction is right. Since the condition was second, so you need to represent as double dash. So at the end, you have to make the summation of all the cases. That means current across 10 ohms is equal to current in 10 ohms in first case, current across 10 ohms in second case. In first case, you got the value as minus 2.86 amperes, and plus in second case, you got the value as minus 12.86 amperes. In this case, you might get the value after adding minus 15.72 amperes, and both the directions were right. That's the reason we added both the current. You cannot add the two value having opposite direction. That's the reason always make it a point both the current direction should be same. Either they can both be right they can both be left, they can both be top, they can both be the bottom. But point is that both the direction has to be same. That's the logic. So this is what the current we obtain by using superposition theorem across 10 ohms. So let's see few more examples in next coming lecture in superposition theorem. Thank you so much for being there. Just make it a point, my dear friends, whenever you solve or you'll be watching our video, just make it a point whenever at the initial stage I draw a network, you please at the same time draw that network, because when I turn my pages you should be having that network, because when I keep on explaining, I write the equation, you should be having the network in your book. That's the only way you'll be getting each and every point what I say over it. So please make it sure you should draw every network when I start with the sum. Please don't have a look at a stretch. Please draw a network. You'll get it more what you will be getting in a video at a stretch. Thank you so much, my dear friend.